When working with a user's private information, it's important that it be sent over a secure connection. For example, take this login form where I accept a user's password. This would normally be sent as plain text unless I use an HTTPS protocol here so that it uses SSL and encrypts the information when it sends it to the server. Now this applies to anything you want kept private, from a user's credit card number to a simple session token stored in a cookie. All of that is not public information, so it should be sent over a secure connection. But the question is, how do we set up SSL and HTTPS in our Rails application and in production? Well, let me show you how in this episode. Now, before I get into configuring your Rails application to require HTTPS connections, let me first show you how to set up your development machine so that you can try this out and see how it works. Because at the moment, in a normal Rails server, if I try visiting an HTTPS request on it, it's just not going to work. So what I need to do is run my Rails application behind something that knows how to handle secure connections. And I'm going to do this with a combination of POW and Nginx. POW is an awesome server for running your Rails applications in development, and what's key here is that it gives each app a consistent domain name on your local machine. And best of all, it's just really easy to install and set up, so just run these few commands. Now, POW does require macOS 10, so if you're on another platform, you could probably just edit your host's config file to point a local domain name to your application. So I'll just run these commands really quickly here. So that command just runs a script to install POW. And once that's done, just go into the POW directory and symlink any Rails application into here. And now instead of accessing our app through localhost port 3000, we can use the name of the app .dev as the domain name, and it will run it through POW. However, HTTPS still does not work. For that, I'm going to use Nginx. As you probably know, Nginx is a lightweight web server, and here I'll primarily use it to handle the SSL communication. Now there are a variety of ways to download and install Nginx, so use the one appropriate for your operating system. If you're on macOS 10, I recommend installing Nginx through Homebrew. It's just a simple brew install Nginx. After that's done, we need to configure Nginx to handle SSL. First I'll go into the config directory, which on this installation is at user local etc/Nginx. Now in here I'm going to generate a self-signed certificate which is needed for SSL. I'll talk more about certificates later, but for now I'll just paste in the commands necessary for doing this. This first command here will generate two files, a private key and a certificate signing request, and when I run this it's going to ask me several questions that I can fill out about the certificate, but I'm going to leave these all at the default just because they aren't really necessary if you're just running it on your local machine here. And then this next command I need to run will generate a certificate file using those two other files, and it will last for 365 days. So run that command and it generates that CRT file. Now that we have a certificate, we can configure Nginx to use it by editing the nginx.conf file. So this is the main configuration file, and this installation has Nginx set up to run under port 8080, but I don't really want to use Nginx for that, so I'm going to comment that out. Instead, I want it to be a server for HTTPS, which there's a commented section right here specifically for this. So I'll uncomment this server section. So this has a server listed on port 443, which is correct, and the server name, I'll set it to anything at .dev to match POW. And the certificate settings should be server.crt and server.key for the certificate key. And everything else can be the same except our location here. I want to use Nginx as a reverse proxy instead of this. So I'll paste in some code to set proxy settings and do a proxy pass to the local host here. So it'll basically pass it to the POW server. And this is very similar to the configuration I used in episode 293. So you can check that out for more information on using it as a reverse proxy. So with those changes, let's try this out. First run sudo nginx-t to test out the configuration file, and this says it's successful, and then just run sudo nginx to start nginx. So with that started, let's see what happens when we visit the HTTPS version of our site now. And we get this warning saying it can't verify the identity of the certificate, but that's expected because it's a self-signed certificate, so just hit continue here, and it works. We can now access an HTTPS version of our site running in development here. So now whether you follow these steps on your local machine or maybe some kind of staging server, it's really nice to be able to experiment with how your application behaves with HTTPS instead of saving it all for production. But let's get started in seeing how we can configure a Rails application to require HTTPS, because normally you want to restrict some pages to only be accessible through HTTPS. First, you should consider making every page in your application secure. This is often done inside of the production config file. There's an option you can specify in here setting force SSL to true. This will make every normal HTTP request redirect to a secure one. However, this is specific to the production environment, and I usually like to move this up into the application config so that way it can apply to any environment that I want to test the SSL connection on. But to make this more flexible, I like to move it out into an environment variable. Let's make one called enable HTTPS, and let's see if it equals yes, since we can't really represent Boolean values very well there. The nice thing about doing it this way is I can add it to the POW config file. So in here I'll export that enable HTTPS setting, setting it to yes. And while I'm here, I can also do other configuration for POW. For example, you might want to change the POW timeout setting because by default it will quit an application after 15 minutes of inactivity, but you might want to bump this up, such as setting it to 3600, which would hold it open for an hour. But you can play around with that if you want to. Now for those config settings to take effect, you'll need to restart POW. And the easiest way I found to do this is by calling this command launchctl stop cx.pow.powd, and it'll launch back up automatically. So with those changes in effect, whenever I make a request to any HTTP version of my application, it'll automatically redirect me to the secure version. So to get this working on my production machine, I would just need to add this environment config, and this is really great because now each developer can have different settings, and if I start my Rails application without using POW, it won't require HTTPS. But now how does that force SSL setting actually work internally? Well, it's done through rack middleware. You can see if I enable it and then call rack middleware here to get a list, it's going to display rack SSL at the top here because that's what that setting adds. Now you may want to check out the source code for rack SSL. It's less than 100 lines of code and kind of interesting. For example, there's this option that enables by default called HSTS. And what this does is basically instruct the client that any requests made to this domain should always use HTTPS for this given amount of time, which defaults to a year. So if you don't want to lock yourself in to SSL, or maybe you want to make your SSL a little more dynamic, you may want to configure this option. And also there's an exclude option, which you can use to customize when HTTPS is required on a request. And if we scroll down to the bottom, there's an interesting method which will mark every cookie that you set in your application as secure. So this means that the client will only send it back to your server if it's over a secure connection. This is great for preventing session hijacking like I showed in the previous episode, but just make sure that you're aware that it's happening. Now, if you want to configure rack SSL in your Rails app, you can do so by passing in this config setting SSL options to a hash, and you can change maybe the HSTS, setting that to false to disable it, or you can change the expires time on that to maybe an hour instead of a year, or whatever time you want it to be, and so on. Now, when you're working with HTTPS, it's important that all included files are fetched over a secure connection. This includes style sheets, JavaScripts, images, and video. So for example, if I go to the home page here, I have this image of an overweight meerkat, and right now it's fetched over an insecure connection. Now when I check out the browser console, you can see I get this warning saying it is fetching insecure content from that URL, and most browsers will give a warning of some kind when you're doing this. To fix this, just make sure that any requests made from your application happen over HTTPS, such as this meerkat image. And now when I reload the page, there's no more warning. Now, it's usually best to host all assets yourself to avoid these problems, but with embedded videos or user content, that isn't always possible. So you may want to make certain sections of your application not use SSL while other sections do. Now, if you want to stick with rack SSL, you could add an exclude option onto here and pass in a proc, but that can get pretty messy, maybe unless you're just changing it based off of a subdomain or something. But normally, if you need dynamic SSL behavior, I suggest not using rack SSL. Now, Rails does provide a force SSL method you can call on your controller for just such an occasion. but I find it doesn't do quite what I want. For example, here's the implementation. It's pretty simple, but one thing it doesn't do is keep flash messages on the redirect. And this is improved in the master branch, which will be Rails 4, but in the meantime, I just prefer to implement it myself. Now, I normally do this in a before filter in the application controller. I'll call it HTTPS redirect, and I'm just going to paste in the code for this. I define two methods here, one called use HTTPS, which should return true or false, and I can override this in other controllers depending on if HTTPS should be used for these requests. And then I have this HTTPS redirect method, which is the before filter, and that checks if either the request is secure and I don't want it secure, or it is not secure and I do want it secure, and then it handles a redirect, keeping the flash messages to the proper protocol. So this means in another controller, such as my home controller here, I can override that method to not use HTTPS here. You'll probably need to restart your app for it to pick up those config changes. You can do so by calling touch temp/restart.txt, and PAL will restart it. Now when I reload this page, which is on the HTTPS version of the home page, it will go to the insecure version, but if I go to another action, which is on another controller, it will use HTTPS. If you're going with this approach, though, watch out for session hijacking attacks like I show in episode 356, and also use secure cookies for private data. Now, one thing that bothers some with this approach is that several links on your site will lead straight to a redirect. For example, on the home page here, this login link goes from an insecure page to a secure page, which will lead to a redirect. So if you want to avoid this, you can pass in a login URL instead of login path and set the protocol option to HTTPS or vice versa if you're going the other way. So you may want to just apply this option to every link that goes across a security border. I have seen some solutions that automate this, but nothing I've been really happy with. I find it easiest just to do it manually like this. And if you forget one, that's not a big problem because there's no really security risk, it just adds a redirect. However, do watch out for forms that submit across a security border. A redirect won't work there, so make sure to specify the protocol. Now once you have your Rails application working the way you want and you're ready to deploy, it's time to go shopping for SSL certificates signed by an authorized provider. Now some providers you might take a look at the prices and be scared off, but don't worry, you can find certificates for much cheaper. A good place to look is your domain name provider. They will often have partnership deals where you can get certificates for pretty cheap. For example, let's say you use DNS Simple for domain name registration, and site certificates here are just $20 per year, quite a bit cheaper. Now, if that is still too expensive, there are some free options available, such as one at startssl.com. I haven't tried it out before, and I probably wouldn't use it for any serious site, but if you're looking for something just a step above a self-signed certificate that won't cause a warning in a browser, you might want to check it out. Now, once you sign up for a certificate, they will likely provide you with several files. Among these is a private key, looking something like this, and a certificate, and they may or may not give you an intermediate certificate. Once you have these files, you can configure your web server. For example, if you're using Apache, it might look something like this. You should first enable mod SSL with a command like this, and then you can set up a virtual host listening on port 443 for that given domain, and turn on the SSL engine, and apply each file to the appropriate configuration option as shown here. Now, as for the Nginx config, that is similar to what I showed earlier in this episode, where you create a server listening on port 443 on that domain, and then pass in the SSL certificate and key files. But notice there's no option here for an intermediate certificate file if you have one. Well, if that's the case, you need to make a certificate chain file by simply concatenating the certificates together. So we'll take the primary certificate file and the intermediate one, and then make a new chain.crt file. So now we have this chain file, which is the merger of both of those, and we just need to pass that in as the SSL certificate in our Nginx config. And finally, you may want to lock these files down so that they're only readable by the root user. So you might do a chmod 400 on all the key and CRT files, and then let's sudo chown the root user on these for that. Well, that's all I have for this episode on adding SSL to your application. Thanks for watching.